I'm Fritz Nelson here at Mobile World Congress in Barcelona. I'm standing here with James Bruce, who's the lead mobile strategist for ARM, the company that is powering all of the mobile devices that we all use. And maybe we should start out with a little bit more on that. I mean, it's not just the mobile phones, it's a lot of things.
Absolutely. If you actually look at ARM, we power, as you said, power a wide range of devices. It can be anything from washing machines through to network infrastructure, and particular devices that we're showing here is with regards to smartphones, tablets, and also we're talking about enabling the mobile infrastructure as well.
So what kinds of infrastructure or devices are you talking about with ARM?
So really we're talking about servers, and we're also talking about the actual base stations and the cells themselves. And one of the critical challenges that mobile operators have at the moment is they're having massive demands on their networks from the perspective of data and also delivering that data. And really working with our partners such as TI and LSI, it really allows them to actually have cells that are smaller, consume less power, and they can also push the servers to the edge to have a lot more network intelligence.
And we always hear about these new chips we've got.
Yeah.
Quad core is one of the big themes coming out of this show, 2012, Mobile World
Yeah.
Congress, and NVIDIA has kind of been the leader there. But we never hear about what ARM is doing to push that. But you guys are behind. You guys are really the starting point for it.
That's right, but I think the important thing to emphasize with regards to ARM is we're about enabling the innovation of our partners. The critical thing is that we actually either license the architecture or license the cores, and then we allow our partners to actually innovate around them. We don't tell them what to do, we just enable them to actually take the ARM processors, design the SoC, put their valuable IP around it, and then come out with these great chips such as the Tegra 3.
So what's new for ARM here at this show?
So beyond all the proof points that you're seeing with our partners, so for example you have NVIDIA with their Tegra 3 showing the 4+1 concept. On the TI booth they're demonstrating the OMAP 5 with the Cortex-A15, and then Qualcomm's demonstrating their latest Cray processors based around the ARM architecture. So some very good demos on the superphone capabilities that will be coming this year or end of this year. The other really impressive demos are actually on entry-level and mass-market smartphones. So you're seeing partners such as Broadcom and MediaTek and Qualcomm actually demonstrating parts that are aimed at smartphones around that sort of $200 price point. And that's going to be a major trend over the next few years, is having a great user experience on these low-cost devices.
Now we're going to take a look at the Windows 8 preview on ARM as well later today. But I'm wondering, as we hear Intel getting into the mobile game, kind of encroaching on ARM territory in some ways, will we see it the other way around?
I wouldn't really sort of phrase it like that. The way I look at it is that consumers, they want great devices with great battery life that's always connected. And as I mentioned earlier, the great thing about the ARM business model is the innovation that really allows these new form factor devices to occur, and also our extremely power efficient architecture. As you compute, as you do more on your devices all day, you want it to last longer.
Great. Well, enough talking about it.
All
Let's
right.
go take a look at some of the demonstrations you guys have here.
Great.
Okay, so we've got 4 smartphones here: HTC, Motorola, Samsung, and some TI and Qualcomm stuff. What are we going to see here?
So really the critical thing about this demo is to show how the user experience has changed so rapidly on smartphones. We've got 4 devices here. The first one was the original Android device, the G1, which came with a ARM 11. The second device we have is the Motorola Droid, which was launched with a 650 megahertz Cortex-A8. We then have the Galaxy Nexus, which is on a dual-core A9. And then we have the HTC device using the latest Cortex-A5. Now what's really interesting is we're running a benchmark from the University of Michigan called B-Bench 2, and all it really does is measure the web rendering time. Okay, and on the original Android device it's taking 13 seconds to go through all the web pages. On the A8, which was a superphone in its time, it's taking about 5.5 seconds. On the latest and greatest Galaxy Nexus, it's only taken 1.2 seconds. So in about 3.5 years, your user experience has improved by over 10x on your superphone. But what's really interesting is this HTC device. This is a mass market smartphone. Now last year, mass market smartphones were basically using the same chip as in the G1, so they would have a web rendering time of about 13 seconds. Now with the Cortex-A5 based parts, the web rendering time has actually gone down to 2 seconds. So what this means is the great user experience that you're seeing on these high-end smartphones is now coming to devices around $200.
Wow. Well, what I expect is devices like this to now allow us to go back in time with the next generation.
Absolutely. That would be a really nice feature, and especially when you're doing a video interview and want to step back and redo it again.
Okay, so one of the things with these multiple cores, it's not just aggregating processors to make it go faster. They're for different tasks, right? Is that what we're seeing in this demo?
Absolutely. This is a demonstration of our next generation technology that you're going to see in smartphones in 2013, and it's called Big. LITTLE. And the reason behind Big. LITTLE is if you look at how you use your smartphone, quite often the tasks that you're doing are actually very low performance, but they're lasting for a very long time. For example, push email, social media. And what we've done with Big. LITTLE is come up with this concept of multi-core, where you have the right size core for the right task. So we have one very small core called the Cortex-A7, and we have a high performance core called the Cortex-A15. And we have a technology demonstration here where what we're doing is we're running Android on a processor simulation of the Cortex-A15 and A7. And what you're seeing here is how Android is switching between the little core and the big core. This is showing your actual load, your performance need of the operating system. And as your performance increases, we're actually switching from the little core, so the entire Android stack, to the big core. We run the task at high performance, or the tasks at high performance, and then we bring it back to the little core.
So really this idea of multi-core is less about, because I always wondered, my phone's pretty fast at dual core. Yeah. Why do I need 4-core? And it's more about efficiency to task rather than just raw speed.
Absolutely. If you actually look at what performance enables, it's a combination of delivering a great user experience, because the last thing you want when you're using your phone is to see that hourglass as you switch between a task and, let's say, an incoming phone call. But it's also, multi-core is also about delivering efficiency, really ensuring that you've got the right size processor for the particular compute task in place.
Okay, so looks like some super high graphics here.
Absolutely. What we're demonstrating here is a production device, the Galaxy S2, and we're really showing the sort of latest and greatest gaming technology running on the quad-core Mali 400. And I think the really important thing to emphasize is, compared to typical games that you get on the Android market today, is the very nice reflection effects that you're seeing. There's the lighting effects, complicated textures, and it's a very good proof point of what you're going to see on your smartphone this year with regards to gaming. If you look at the quality of this and compare it to gaming consoles, this probably would be best described as PlayStation 2.5. And a really interesting trend is, as you go into 2013, you're going to see Mali T600 devices, and that's actually going to deliver a PlayStation 3 gaming experience on a mobile device.
Mali is a graphics processor.
It's a graphics processor. And I think back to the demonstration that we were showing earlier with regards to right-size computing, what you're seeing now is it's not just the CPU, it's the GPU. So the GPU is being used to actually render your UI, obviously for gaming. But the next thing you're going to see is something called GPU compute, where you actually offload certain computational tasks to the actual GPU. So for example, photo editing, where you're actually doing the effects on the photo, actually makes much more sense to do that on the GPU than on the CPU.
And is the Mali being used in any devices? Is that a prototype or an actual production device?
That's a production device. So we've got the Galaxy S2.
Oh, that's the S2, okay.
That's right, yep. We have the Galaxy Tab 7.7. We have a HTC device. And we also have the Samsung Note.
James, that's obviously several demonstrations of the things that are happening now. But we look out over the next couple of years, and I mean last year I think TI was showing a little bit the early preview of OMAP 5. This year a little bit more robust, it's shipping now. What can we expect from smartphones in the next couple of years, and when are we going to start hearing 8-core, for example?
I don't think you're going to see a trend towards 8-core, but what you are going to see with your smartphone over the next couple of years is it's really going to become your primary compute device. Earlier I was showing you the Cortex-A15 demo, and you have the OMAP 5 with Cortex-A15, and that actually has enough compute performance for all your needs, including laptop type applications. So I think what you're going to see is that you really are going to use your smartphone as your media hub, as your laptop replacement, and obviously with LTE connections coming into place, you've now got the seamless connection between your device and the network, so you can access content stored on the device or in the cloud.
Great. Well, thank you so much for showing us all of that.
It was great talking to you.